Hey, this is Steven from LegitTechTutorials, and welcome back to video 3 on my product design videos of the multi-shooter dimensional control and automatic spooler modules. So like I said, these modules bolt onto the multi-shooter and they basically spool up filament, and while spooling up filament they pull the filament to size so that is correct size, either 1.75, 3.00 millimeter, or anywhere in between that you want. So last time that we worked on this, we did the roller of the dimensional control, and this one might be a little different. Reason being is I accidentally, last time we did it, I turned off my computer and I lost all the data, so I just redid this really quick. So it could be a little different, but at the end we'll end up with the same thing after I print it and then fix it up. And one thing that you might note is that I did extrude that cylinder all the way down, because on 3D printer you don't have any overhangs. So here everything should be just fine. Alright, so what we're going to do today is we're going to design the brackets. So we're going to design the brackets that hold up this particular part here, and then at the top it's going to have little holes for the pressure sensors, for the FSRs, the force sensor relays. So what we're going to do is, what I know is that this hole that I have right here is for a shaft that's 0.1 inch, and also another thing on this is we're going to be doing inch, and then all you have to do at the end is turn it into millimeters, and everything's fine. Okay, so they are going to be square. They're going to be square brackets. They're going to be 2 on each side, and remember that this is only one of the 2 spools. So there's going to be 2 spools that have to ride on this one bracket, and one spool has to be stationary and constrained to where it just rotates and it does not move X, Y, and Z, and this one to move just a Z, I guess you could say, but and also rotate. So what we're going to do is, like I said, we're working in inch. I got another file open here, and we're just going to start doing a sketch on the flat plane here. And what we're going to do is we're going to have this, again, is going to attach to a piece of square steel, tube steel. And the square tube steel is, the square tube steel is 5/8 by 5/8. So that's 6.25 inch by 0.625 inch. Is it 5? Yeah, so 5/8 and 3/4 is what I got. Okay, so this is the steel piece, and then of course we're gonna add 0.63 or whatever. It's gonna have a little bit over so that it slides on there correctly. And then we're also going to put a little hole in the back for a set screw, so that you could put a set screw in there to keep it from falling, because there's going to be a lot of weight on here, and it's going to be cantilevered out, so it shouldn't be that big of a deal. Okay, so we have that guy, and then what we're going to do is we're going to have the brackets come out. And another thing is that this guy is going to be depending. What did I do? I think this one I just made 2 inch. So we'll just have it be 2 inch for right now. Like I said, we're just doing it roughly. 2 inch seems fine for me. So let's go ahead and do that. So what we're gonna do is we're just gonna draw a first off. What I'm going to do is I'm just going to draw a 45-degree line. So 45 is equal. I'm just going to draw out to the side. This is going to be the gap piece. This is just going to be 1 inch. So it's 2 inch diameter. So from the middle here, it's going to be 1 inch. Put that over there somewhere. And from here, it's going to be 1 inch. And then, of course, you could constrain them to be equal. This one's equal to that one. It's overly constrained because it already says 1 inch. But you could delete that. make this one equal that one. Alright, so 1 inch, 1 inch, and then what we're going to do is we're just going to do, for right now, just have a diagonal here. Go out to that line. And then that part right there is 2 inch, so this is going to be the sidewall here. So then we have it, each cylinder is, where did I have it set? I had it set to, let's go ahead and edit the sketch. So it's 2 inch diameter, which is what I want. So that means that it's going to be 4 inches total plus the filament in between, plus 2 mil, which is pretty much nothing. So what we're going to do is just we're going to make it 4.1 inch or so. So down this way, 4.1 inch. Right. It's going to be 4.1 inch. And then what I'm going to do is I'm just going to delete that and make these two equal. This one. Okay. So now what we're going to do is we're going to square this up for right now. Not going to go for anything super crazy as far as the design here. And then we'll probably put some gussets in here or something. Okay, so let's just go straight across here, and then this should be, I think, what increments are these? This is half an inch increment. Okay. Oops. Sorry about that. Okay. So there you go, half an inch increment. There's another half an inch increment. You're probably gonna definitely need to be thicker than that in order to hold. You know, it's not a lot of weight, but you don't want anybody to like hit it and it fall over or anything like that. So yeah, it's constrained over here. This piece is constrained or something. These aren't even straight. Okay, so what we're going to do is just going to do a line. And we're going to dimension this here. And we're going to delete this one. This one's not even straight. Dimension this guy. And then these two are going to be equal. Okay. Let's draw a line down. Okay. Alright, there you go. Now it works correctly. Alright. So, now that we have that done, what we're going to do is, another thing that we're going to do is I'm going to square this up. So I'm going to basically put a rectangle there. Let's do 2 point to cross it. So let's make this 1/4 inch. So there we go. Now it's going to have some rigidity here because it's closed there. So these two are going to have some rigidity. All right. Then what we're going to do is we're going to extrude this. Extrude everything except for obviously that centerpiece, and I'm gonna have to have something over here on the back, so there's gonna be a piece over here in the back. I'm sure we should probably do right now. And then over here in the front too. Oh, no. Let's just do that for right now. It's definitely not enough to get it to become rigid, but for right now, that's what we're going to do. Okay. All right, and because, like I said, we're 3D printing this, we need to get it to where it is a, a size that could be printed pretty efficiently. So 1/2 inch is pretty big. So we're gonna go for that because we need the rigidity. All right, so there we go. There's our shape. Here's a little reinforcement. Obviously not gonna work not gonna work very well. We're going to need to reinforce this area here. And most likely do a lot of reinforcement in the back and then a little bit in the front. Let's probably make another square. So let's do that right now. Then what we'll do is we'll just make that guy longer. Oops. Alright, so it just automatically added that. And another thing is I noticed that it extruded this piece. Don't want to extrude that piece. Okay. So now we have that, and now what we're going to do is we're going to start drilling holes on the side where each one's going to go. And so now if you could think, this is vertical, this center piece is like, this is the XY plane, and the Z plane's up and down. And the pipe goes through the center, so this is like cantilevering out forward. So the filament is going to go down through this section here somewhere. So this piece here, one roller is going to be mounted here, in this place, and it's just going to spin. The other roller is going to move up and down, so this will be slotted here. So what we're going to do is we're going to go on the right side. We're going to create a sketch on the face, and then what we want to do is we want to project or include this particular line here, this particular corner. Alright, so now we've projected that corner. Now obviously we're going to use the center line here. And we're going to go over 2 inches to 2 1/8 or so. Give it a 1/8. Okay, so now that is our point, and then that's just going to be drilled through. And what we're going to use is we're going to use that size. I mean, you could do a hole. For this case, I'm just going to do a circle because I could do it all in one sketch. I don't have to, Sometimes holes are good. I usually just use holes for tapping reasons and stuff like that. But you could do circles and just extrude it through. So you could extrude everything at once instead of having a whole bunch of holes with different sizes and stuff. So this is going to be 0.10. And that's going to be the size of the hole. And then that's going to be extruded all the way through. And then what you have, I made this 2 inches. This is actually supposed to be only 1 1/4. 1 1/8. And then you get issues there. Project include. I mean, this is already projected included. So what we're going to do is going to make these two parallel. This one parallel that one. Okay. So now that's constrained. And then I also, another constraint is probably going to say that this is over constraining, but whatever. Yep. Okay. So it's 1.25. And our next thing we're going to do is we're going to do an error line give it 1 1/4, 1 1/8, sorry, another 1 1/8, and then that's going to be the next pin. No, sorry, that's the end of that pin. 1 1/4 is the end of that pin, so we're going to go over another 1 1/4, 1.125. So there's our next pin there. This is just going to be, it's going to make it as whatever, delete that, and then make these two equal. There we go. Okay, so there's our second pin. Now, the thing about this pin is that it's going to be moving back and forth. And so what we need to do is we need to have it have a, you know, like an area to move. So we need to cut from this point where this other pin is. We're just going to cut all the way across. So what I'm going to do for whatever reason this is defaulting. Okay. I'm going to put a point, 2 points. This one I don't think I clicked on the line. I don't think it coincided with that corner. I don't know why this thing is doing that. 180. Thank you. Thank you. Okay, and then the next thing that we're going to want to do is we're going to project this corner again so we don't cut through the corner. So we don't cut through the support here. So we're going to project, include that corner. Alright, so we're just going to have it do that pretty much. Okay, obviously the next thing that we need to do is we need to escape that. We're going to go back to this first sketch and then change this to plus that other one. So let's just make this like 4.5 inches. Uh-oh. Some stuff's not constrained. Crap. It's not constrained. This is not equal to that. This one's not equal to that. Okay. 4.5. There we go. Okay. So now we're going to go back to the others that are sketch. Alright, now this is good. This is constrained. This is going to be slotted. Don't really need that. That's just the rest of the line. Make sure it's straight. Actually, what I could do is put that line back. Make that a construction line. There we go. Just make that construction line. Okay. Alright, so now what we're going to do is we're going to go ahead and extrude these. So I'm going to extrude. Oh, this is not closed. There we go. Okay. Let's do that, and that. We're going to go from one side to the next side. So now we have the channels that the rollers are going to travel in. We have a reinforced shape here. Plus the space here. Should be the right. Should be all set up correctly. Shoot it on one side. We did it all with, you know, four sketches. So now the other thing is how to make this, you know, slide efficiently so it does, you know, squeak and stuff like that. And also we need the springs. And actually how I'm going to do that, how I'm going to do the springs, is I'm going to do the springs on the outside here. So there's going to be like little squares on the back side of those pins. And then they ride up and down this channel, and then they go here. So what I'm going to do is I'm going to do a little perch back off of on this guy. So let's do a little perch. What I mean by a perch, you'll see in a second. So what I'm going to do again is I'll do in the center of this guy. That's not what I wanted. Let's do another rectangle. Another rectangle from here. Oops. I don't know why the hell it keeps doing that. Okay. Rectangle from this point, about a 1/4 inch, and then we're gonna do it to about this point or so. That seems fine. And then what I'm gonna do is I'm just gonna have it constrain the point from here to here, which is 1/4 inch. And then I'm gonna do the same over here. This is going to be 0.25. This is going to be out to wherever this is here. And then this, I'm going to also sketch dimension here to here. 0.25, 0.25. And then what I'm going to do is I'm just going to make these two lines equal. Make up both these equal. This is equal to that. This is equal to that. This is over constrained, that's fine because it's rectangular or whatever. Oh. This one. Okay. So we got our little perches. Now that I'm looking at it, they're definitely going to need to be longer. So what I'm going to do is return this 0.5. And there you go. Okay, so there's our little spring perches. So these are our spring slash FSR perches. And now what I'm going to do is I'm going to do a sketch on both of these to get them to be correct. I don't know if in actuality I'm going to do 2 FSRs or 1 FSR. I'll probably do just one. But let's go ahead and go back to the right side so we don't get all confused about which side we're doing stuff on. Alright, so let's go ahead and start drawing our perch. First thing, I'm going to find center line. Then draw 2 construction lines. Put a point in the center. There's our point. And then let's just say that we have a specific. So this is going to be the FSR perch. This is going to be the FSR side. And I actually have one over here somewhere. I think should be. Pretty sure I have one over here somewhere. Ah, here it is. Okay. So here's my little FSR. Really cheap, nice sensors. Like I said, not very good for absolute, but pretty good for reference. Between after you calibrate the sensor to be the same. So I'm just going ahead and it's pretty much 3/4 diameter for the most part. And of course these will be glued down, to some point. There's my cat again. So let's make this 0.75. Wait, what? Interesting. So yeah, 0.75. That's okay. So if that's the case, then what I'll do. Let's take a look real quick. And it said that was constrained. There we go. That's what happens when stuff's not constrained. Okay. Now what I'm going to do is go to my next one. What was it? First one? First one? First one. Okay. I'm going to put this. And then actually what I just did is not going to work. You'll see why in a second. Because this guy is going to have to be, oops. This guy is going to have to be like 0.8 inch. Okay. And I got a 0.8 inch. I need this other one. 0.8 inch. Okay, so now what that means is that this piece here can be 0.8 inch, and then the interior be 0.75. And there is our little lip to hold it in there. And then what we need is we need to have a cut inside for the little wire to come out. And now if we are making this the top, we want the wire to come out through the top. So here's the top. So we'll make the wire come out that way. So, oops. Okay, so here's the top. What we have here. Just make sure calibrate here. I'm measuring the little wire that comes out. Thickness is 0.30. So let's do 0.35. 0.35. Okay, rectangle. Center point rectangle. Off over here to the distance somewhere. 0.35. That's fine. Okay. This doesn't need to be constrained. It could be whatever as long as it goes off. Oops. Nah, that's fine. Whatever. Oh, this is not supposed to be 0.35. I meant to do this one. 0.35. Okay. So what I'm basically going to tell it to do is not extrude that part, pretty much. Alright, so now after that's done, what I'm going to do actually is I'm going to make them on both sides. And then put a point. I'm going to put a circle, 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 0.75, 0.75. And then for right now, like I said, I think I'm only going to have one sensor for right now. Is, you know, cost savings. So what I'm going to do is extrude. I extrude that. As you see, I'm extruding everything except for that piece. Oops. And then I need to make sure that it's extruding the right way. This is going to be out. That's fine. Okay. So there are the spring perches. And then probably what I'll do is I'm going to have a little cap. A little cap piece that basically caps this. What happened? I think I'm on the wrong side. Ah, there we are. So there you see the little hole that this band comes out. So what I'm going to do is I'm going to have a 3D printed cap so it distributes all the force. So basically it's a piece that goes on top of the FSR, the little circle resistor, and there's a little cap that goes on top. So and then this similar principle on top of that cap, so that it causes it not to the spring, because the spring could not be 3/4 inch. So it causes it not to, you know, move around or anything like that, and also to distribute the entire force rather than on just the center. All right, so that is pretty much all that I could think about as far as this particular piece is concerned. So again, what we created here is we create the bracket that this roller will. Two rollers will ride in. One would be constrained over here to just spin. The other one, let me see a line. The other one will be constrained to move forward and backward. How I'm going to make this smooth, probably just smack some grease in there or something. Just make it smooth like that. To move up and down, because you need it to move smoothly up and down in order to have, you know, good reading on the filament diameter. Alright, so that is pretty much it. We got, you know, the 5/8 hole here for the 5/8 tube. We got some supports. We got the spring/sensor perches up here that will ride on this guy and push this guy into this other piece here. So we are ready to go. We're gonna have to later on do the pins that hold the dimensional control together. And then at that point, we are pretty much done. I mean, we could take a look at, you know, printing some bearings for the rollers so that they roll. If you remember, we have these little holsters here for the bearings, so that they spin freely. So we might also catch that, take a look at that. All right, guys. Well, this has been Steven from LegitTechTutorials. I'd like to thank you guys again for watching my video on the multi-shooter dimensional control, as well as automatic spooler. If you like this series, please subscribe for more videos like it and more series like it on my channel. And I will see you guys in the next video. Thank you guys for watching. Take it easy. Peace. Have a good day.